Hi, everybody. Thank you for joining us on this new approaches to cost optimization webinar. I'm Asaf. I'm one of the co-founders and CEO of Granulate, and I let my co-hosts introduce themselves.
Howdy, I'm Quinn. I have a passion for effectively bringing sarcasm and wit to an industry that otherwise would be incredibly dry, which of course coincides with my day job of fixing the horrifying AWS bill in a consulting capacity. So anytime a company has something that is aimed at a space of optimizing for performance or improving cost, I generally have loud and angry opinions. And today I've been invited here to share some of them with you. Remember, it was your choice to watch this. It's on you.
Hi, everyone. This is Bailey Caldwell, formerly with Flexera and prior to that RightScale for 10 years, here to talk to you about the Granulate real-time continuous optimization engine.
So thank you all for joining us, and we'll walk you through these new approaches as we go along. Basically, maybe a few words about Granulate at first. What you can see is that these are some of the numbers that we've been getting with our customers. Our main goal is to help customers handle their workloads with anywhere between 20 and all the way up to 80% performance improvements. Quick note about no code changes. Basically, Granulate was built on the premise that a lot of organizations are using Linux in production systems, and Linux was built with a user behind the keyboard in mind, so aimed at interactivity and fairness. This means that everything's unopinionated and made to be very responsive to whatever is currently happening. However, we measure performance of a server by response time, throughput, IOPS, whatnot. And Granulate wants to align those optimization functions, and that's how we see all these gains.
Since the early days of cloud, right, everyone thought that moving into cloud would actually save you money. It turns out that that's not necessarily the case, especially when you just use a lift and shift approach. So for years at RightScale and at many other companies, cloud cost management has become an increasingly difficult problem to solve. And it's time for a new approach, a new way of also attacking the cost problem at the source. So whether you're working on cost visibility, on right sizing, scheduling operations, or discount plans, all of these are valid savings techniques. But what Granulate has come up with is a way to solve the cost problem where it begins, which is at the provisioning process and how you actually design your infrastructure and make it as optimal and efficient as possible.
It's easy to wind up viewing cloud optimization or performance optimization as this thing that is this far future approach. But basically speaking, there's something of a maturity model that people tend to iterate through. And spoiler, no one has ever talked about this and not then looked at their own environment and felt embarrassed by what they say. No one feels that they have a lock on this. So I want to be very clear, this is not a name and shame exercise. That's part two. Instead, it's, okay, great, let's look around any given cloud environment when cost becomes an issue, and left to its own devices, it will always become an issue because you're paying for what, not for what you're using, but for what instead you've forgotten to turn off. And it will continue to churn indefinitely until someone in finance notices. And believe me, they will eventually notice. And there's an iterative approach here. Step one, turn off things you're not using. Remember that whole data warehouse, secondary data warehouse that it turned out seemed like a good idea for 10 minutes back in 2013, but then no one bothered to follow up on that? Yeah, maybe turn that off. And then, all right, the first 10% is relatively easy to find. The second 10% might require some iterative work on, okay, reserved instances, savings plans, optimization of storage classes. Great. Then beyond that, you start getting into weird architectural things where, okay, now we're looking at how the application communicates, both to itself as well as to other components outside of the ecosystem, and what those traffic patterns look like. And to see significant savings there, you usually wind up having to do some form of optimization pass toward that speaks to architecture and changing the way that different components interrelate. And again, these are very generalized buckets. What I find interesting about Granulate is they're going in a bit of a different direction here entirely.
So as I said earlier, what's really different about the Granulate solution is that it works within the context of all your other optimizations, whether that's reactive in terms of looking at a bill and understanding that you've overspent, proactive in terms of planning and right-sizing your infrastructure, and also this new generation of continuous real-time performance, which I would describe as active. the system's actually going to modify at runtime based on the code and the application requirements for your infrastructure to perform as well as it possibly can.
There's a lot of stories out there of you look at a company and they have a fleet of 20,000 instances that are all the same type and family. Great, so why do you pick that one? And there's a whole story that goes around this. The actual reason is 4 years ago, some engineer who was building this thing for the first time picked that one out of a list because, okay, that sounds about right. We can always dial it in later. Later never really comes. And in many cases, that's not inherently a bad thing. You're never going to cost optimize your way to your next milestone. It's a trailing function, not something that actively propels the business forward in most cases. So there's always something else to focus on until the bill becomes untenable, at which point it feels like we've been doing this wrong forever. Maybe not. If you focused on building something for the least possible amount of money from day one, you very likely would never have succeeded to the point to even have that conversation. It's worth pointing out, too, that you have to walk before you can run on some point, to some level. Otherwise, you're optimizing for a story where your environment is great. We're going to optimize the heck out of this. And you look across the fleet and it's seeing an average CPU utilization of 7% or something. Great. Maybe work on a better optimization story first. Maybe introduce this rando thing called auto scaling into your environment. Maybe consider whether you're taking advantage of elasticity, which is always one of the cloud's selling points that people tend to lag a little bit on really leveraging. Yeah, I think that your model makes sense from certain points of view. The challenge is it speaks on some level more towards the idea of tooling and what to wind up implementing in any given environment. And it doesn't necessarily speak to the biggest obstacle in driving any sort of change like this, which is, of course, culture. There's a question of how do you wind up caring about cost? How do you wind up socializing a shared vision for that? How do you empower people to save money and understand what things cost, but have enough insight to know that they're making the right decision? Developers will love to spend 8 weeks doing nothing other than knocking $200 a month off their development environment expenses. They cost more than that by the first hour on their first day, so maybe that's not material to the business. It's also worth pointing out, with like any good maturity model, some teams and some organizations will need to attain top-tier status. They'll hit the mastery point on it, but not every team needs to do that on every aspect of every maturity model they wind up seeing. This is clearly something that winds up making sense for companies and teams that meet specific profiles. And within that profile, for a certain bounded set of problems, yeah, I have no problem with this particular model. I would hesitate to say that it makes logical sense as a panacea across every different environment. I would say that they might want to question where they're coming from on this, because the biggest problem that I find in the entire world of cost optimization is people dive in without a nuanced understanding of what their goals are. Sometimes those goals are easy to identify. Knock 10% off of our cloud bill. Great. There's a path to get there. Save as much money as possible is one of those dangerous positions, because at some point you're in a tension between what needs to happen from a good best practices point of view and what makes sense to save the most amount of money possible. Theoretically, you can save the most money by turning your entire environment off, but remarkably few companies should do that other than Facebook. So the pain point that you keep smacking into then is, great, which of these things apply to me? A more nuanced example might be a bunch of data lives in an S3 bucket that's core and central to your environment. You could save money by reducing its cost by moving it to infrequent access one zone, but if that bucket goes away and your business is in peril, I'd argue instead you spend more and back that up somewhere else, because, spoiler, it is incredibly easy to fat finger the wrong command on the wrong bucket and accidentally drop the data warehouse into the sea. So there's always going to be this tension between saving money and not saving money.
So these are the new approaches that we see if we put it on a performance versus cost matrix. We talked about all these approaches that came out with just the movement to the cloud and the migrations, all the cloud hygiene and stuff. But what we're seeing right now is what we call resource performance optimization, and that divides into 3 categories, all very autonomous, all low maintenance, and aimed at, again, cost and performance. So if we look at the traditional APM and AI ops tools, they're aimed at root cause analysis, they're aimed at alert consolidation, basically all the things that we need to investigate any issues that we see in production. But as we moved forward, cloud costs, both monitoring and optimization, became huge issues. So a lot of organizations tend to that as well. And we've seen some automation in that space, both scheduling operations and auto scaling. But as we move forward, we're seeing three different approaches that are emerging. One is configuration tuning. Basically, if you look at it, you see a huge amount of components that you have in your system. And probably if you're carrying a legacy of 10, 20 years of code, you probably didn't go back, and as any new generation of hardware came in, you didn't change all the configuration. So you might carry in a lot of legacy changes that have to be done. And let's face it, no human could probably do that. So it makes sense that we would input into place some sort of configuration manager. There are some players out there that do that. But the truth is, it's going to give a huge bang right out of the bat, but we're not going to insert 2,500 new components every month or even every year. So it's not necessarily going to be the best approach, but again, it's definitely better than nothing. Another approach is the resource workload orchestrators. Basically, we're seeing more and more orchestrators put in production, whether it's Kubernetes, whether it's the auto scaling, and we're adding the ability to vertically scale and horizontally scale our own production environment. And since everything has to happen in real time, everything has to be very proactive and reactive to what's happening, we want something to do that is autonomous, that is much better at doing that than any human could possibly be if he monitors the entire system at any given point in time. But we do have to remember that all of these are aimed at the cost effectiveness of our resource usage, because scaling down a machine that's underutilized is not going to increase the performance of our application. It's just going to make sure that we don't pay as much for the same piece of code that we're running. And that's where the real-time continuous optimization comes into play. Because basically what we want to say is that no matter what size of machine you're using, currently the machine itself is not aimed at whatever it is that you're measuring the application by, because you're measuring it for throughput, IOPS, latency, but your machine is aimed for responsiveness to whatever it is a user is currently doing. So it's very unopinionated. What we want to do is tailor everything to the application itself. Thus, you're gaining both performance and costs. Whether it's a large machine or a smaller machine, it doesn't matter. And it doesn't matter if it costs more or it costs less. You want something that in real time will give you the best performance possible. And if you can scale down the machine, but still you want to make sure that you get the best performance out of it.
Yeah, I agree wholeheartedly. I think that there's definitely going to be a bunch of challenging aspects to understanding what is happening in your environment. Things like workload orchestration and moving into this microservices paradigm that turns every outage into a complex murder mystery means that no one's really sure anymore what's going on where. I would argue that having something automatically adjusting these things, if you need to take that approach, it's no longer optional that this be automated, because no one is going to be able to hold all of these relevant facts in their head, nor would you necessarily want them to.
Yeah, I think one of the most interesting things about that is what happens if there's an error. So what happens if there's a mistake? I think that's true for all the autonomous approaches in general. And I think a lot of our viewers would be very, very worried about that. And I think that probably the right argument there is that similarly, or there's more chance that we'll have a human error versus one of these things break. I think that if you look at the more time that you run it and the amount of companies where it makes the decisions versus the expertise of a few people managing a huge infrastructure, there's good chance that automatic decisions would be much better.
In the common case, yes, but edge cases are always what slice you to pieces on this. The challenge is, okay, I'm looking at your environment. There's a scale down story here. We're going to optimize this because you're way over provisioned. Then you dig into it a bit and, it turns out next week is Black Friday and you're a retailer. You've been intentionally optimizing for traffic that isn't there yet. Or alternately, that's your DR site. It usually is designed to sit there idle and unused, but you're going to need it with a very small notification window before it hits. So it's got to be ready to go. So on some level, having some point of oversight to ensure that whatever your automation is doing does not conflict with business priorities is necessary. But again, letting things run rampant in production and automatically make changes with no guidance, oversight, or reporting is generally not what companies try to do.
Yeah, and probably not advisable as well. So finally, we can discuss a bit about real-time continuous optimization. I think the notion of making everything a little more application aware, sort of mashing together the fact that your own application has its own needs and stopping with the general purpose infrastructure, general purpose runtimes, and make sure that your application gets a tailored environment. I think these are obviously, as the name implies, run in real time, do everything online, and make sure that it's reacting and preventing a lot of infrastructure issues. Again, I think this is something that has to be autonomous. You can't handle manual decisions to, thread scheduling. That doesn't make sense time-wise. But as you mentioned, always have to have the ability to make sure that I understand what it's optimizing for and that I can configure that. I think otherwise that'll be, as you mentioned, sometimes too smart for its own good. Shut down the entire application, return 200 no data, 204 no data on everything. You get the best latency possible.
Exactly. Just return absolutely no data, lose everything that held still long enough, and then blame the customer for it. I'm pretty sure that's the MongoDB strategy.
Fair enough. So let's maybe dive deep a bit on a few examples of configuration tuning to start with. I think if we look at the many knobs to turn, we gave here a few examples, whether it's the application level, we gave you a few examples on Nginx, all the way to runtime environments, so JVM, Ruby, so on. syscontrols in the operating system, I'm pretty sure a lot of people are aware of that. And finally, you can reach, or you can decide that even cloud offerings like GPU compute or compute optimized machine types could also be a configuration. I think one of the main arguments to that is, why not do all of these or turn those knobs in real time as things change?
This is where it starts getting really interesting in figuring out what knobs actually need to be turned. Brendan Gregg's work on performance tuning, especially in the world of cloud environments, has been some of the seminal work in this space. But the takeaway for the rest of us is, if you don't happen to work at Netflix and have a massive scale and incredibly talented group of people working on this is stuff that's good to know, but really only gets applied to the most egregious examples of things. What you're proposing is to automate a lot of that heavy lifting out for things that are now understood and well known that can be tuned, where most folks generally don't tend to have that expertise locked away in their own heads.
Yeah. So I think as you mentioned, this could probably be something that you sort of help people gain the same benefits as you're seeing at Netflix and stuff like that. I do agree that a lot of it doesn't have to be automated, since you can apply it once and then see the benefits for years to come.
Your web application runs on 5 instances, maybe there's not a lot of gain to be made in optimizing those environments. It's easy to fall into the trap of talking about large-scale footprints, but let's not kid ourselves here. At some point, you need a certain point of scale before the bill becomes even slightly relevant and performance bottlenecks begin to be something of a consideration. It's a good idea to know where you're at bottlenecks as it continues to scale. But if you're doing the math out and realizing that you're going to start hitting bottlenecks when your user traffic is 5 times the population of the planet, maybe maybe that's not the first thing to optimize for at this point. What I like about the automated approach is you can start building some of that reasoning capacity in.
So let's talk about one of these automated approaches, which is the workload orchestration. I think the sweet spot for workload orchestrators is somewhere towards the utilization. So you don't necessarily gain the maximal quality of service. You want to remain at a certain cost effectiveness. So you've got your three key decisions would be how do I size my machine, how do I size my pod or container, and how much do I provision, so more machines, less machines, and so on, and where do I place my application. So I think if you're talking about autonomous operations, this should be a good start. Even if you've got a small amount of machines, you probably don't want to tackle these every day. So I think this is a good thing to implement in general.
Absolutely. There's a reason that a load balancer is an appliance you can use and not a job description for someone. It'd be the worst job in the world.
What is real-time continuous optimization? A year ago, I bought a Tacoma truck and it was a little underpowered to tow my camping gear behind it. So I came across this pedal commander, right, which goes between the accelerator and the engine, and it essentially tunes the engine for the workload. So if you're towing camping gear or driving off-road, it's going to change the performance of the engine. If you're on the highway, it's going to modify how it performs. It's sort of like sport mode, right? And the way I think of Granulate in a simplistic view of the world is that it's sport mode for your Linux servers. It's going to understand what the workload is and modify the performance of the operating system with zero code changes to make sure that the infrastructure you're running is as efficient as possible. So how does that work? Well, ultimately, as I said, there's no code changes. And what the agent does is it observes the actual workloads that's running on the Linux server, and it determines what the best configuration is for the kernel. It'll modify it based on network I/O or disk I/O, depending on the workload and the application that you're trying to run for the environment that you're running it in. It's also infrastructure agnostic. So it works on cloud, on-premise, in Kubernetes, across all of the application architectures you want to run to support your business.
I think in terms of, we talked about becoming application aware. So with real-time continuous optimization, that's basically what we want to do. We want to change those optimization functions that are built in with the kernel, are built in with the runtime, make sure that we tailor everything to the application in real time. And just to give an example for the viewers that are not well familiar with the space, the point is, sometimes you could be optimizing for the here and now, and you end up harming the overall. So we'll give a short example. So let's assume that we're focusing on a single server on service A right here. And that service is going to receive some request. For the sake of example, let's assume it's a login request. So we want to verify the user is logged in correctly. We want to give him some new insights, what's history, maybe some recommendations and so on. And since a lot of it is independent, we are going to probably query a lot of the services at the same time. Usually creating just 3 downstream requests for every login request would be very small. We usually see tens to hundreds. And what would happen is at some point, one of these is going to come back. And from an application standpoint, if we're talking about async IO, we're going to poll, we're going to see that the file descriptor is ready. From a threaded application perspective, the thread is probably going to wake up and start dealing with that data. And what we'll see is that from the application perspective, this is not necessarily the best thing, because what's happening is when we process data from service X right here, we might actually delay something else to wait on that processing. For example, other login requests for other users, data that has come back for other login requests and may be ready to be sent back to the user, and so on. So we're not necessarily doing the highest priority thing, even from this particular request's perspective, because for the sake of the network example, it'll probably take us a few microseconds to process the data from service X while we're still waiting on services Y and Z in an order of magnitude of milliseconds. So we can probably lower the priority of service X's data while still not changing the overall response time for this particular request.
Right. You effectively wind up optimizing for your slowest service, at which point everything else can become deprioritized. You wind up able to build a bit of a queue for that to be processed. No, it makes perfect sense.
Thank you. Really appreciate that it's understood from this. It's not that easy. And so if you've seen that, then you probably understand why when services Y and Z return a response, all of a sudden this becomes a much higher priority. Right now, you have the ability to return back a response to the user. Maybe you can free up some resources, and so you can finally reduce contention by prioritizing correctly, not by just throwing money at the problem and purchasing more resources. However, from the kernel perspective, from the operating system perspective, if we go back to that, again, these are just file descriptors that may be ready. Maybe we have other file descriptors ready, like we mentioned earlier. And maybe we have other threads running on the CPU instead of us, and so on.
Presumably this has to happen at large scale where there's a pattern of behavior that can be identified on a consistent ongoing basis. I have a hard time envisioning that you're going to be able to make changes that are meaningful on a scale of microseconds for individual requests.
Absolutely. So it has to be a service that's serving or is a little, at least, seeing a load. So you can see that on a test environment where you have no contention on any resource. So prioritization just doesn't make any sense. You're always number one priority.
Gotcha. That's how I tend to view the world. I'm always number one priority.
Fair enough. That was a good one. So obviously the way that Granulate does that is, since there's no API to tell the kernel that we want to prioritize certain things versus other ones within the context of the same process, we can only do that between processes, but the kernel was built for interactivity and fairness. It's really good at prioritizing that. So within the context of the same process, we want the user to tell us what's the optimization function. So is it the response time? Is it the throughput? Is it the IOPS? Whatnot. And then you have to hook into those contended resources. So CPU, network, synchronization mechanisms like locks, mutexes, atomic operations, and so on. And you can, as you mentioned, if you have that repetitive pattern, you can improve the performance and you can make decisions that are much better. And so you can actually reduce your compute costs because you can scale a lot later, or you can reduce latency and go back to the SLA that you were used to by increasing throughput on the machine, and so on.
On some level, it seems like focusing on the cost benefit is almost the wrong lens to look at this through. In being able to improve request performance, being able to build out something that functions in a responsible, achievable way of effectively, for not a lot of engineering investment, being able to boost performance on services, that has the potential to add significant value to a business that goes well beyond saving money on a bill.
So we see a lot of verticals where performance actually impacts revenue. I think there's a lot of studies that have talked about conversion rates and upselling in e-commerce that go up.
E-commerce cares about it. Ad tech cares about anything that's even slightly competitive will care about it. It's people listening to this or watching this are going to absolutely say, wait a minute, you can improve performance. Forget everything you just said about cost. That's the thing that I care about. That's the sort of thing that gets people to sit bolt upright and take serious notice. Generally, in my experience, when you find someone who sits bolt upright and pays attention to, wait, you can save me money, that's usually the sign of a bill that's gone a little too long without tending.
So I think that's one of the things that we've seen actually during COVID times. I think for a lot of people that has been sort of a reckoning that has been a long time coming. People felt like business is going well. We don't need to necessarily care about the OpEx right now. But COVID has definitely changed that, either for better or for worse. We see a lot of companies with a business model where traffic has no impact on the revenue. For example, you pay for Netflix the same amount whether you watch it 2 hours a month or 3 hours a day. So Netflix is seeing a huge uptick on its back-end pressure, even though the revenue per person has probably not gone up.
Well, you see the same thing in a more depressing way when you see traffic drop off a cliff, but the infrastructure spend holds steady, because it turns out that auto scaling was an aspirational goal and everything has been built like a pet, and it becomes this steady state environment where you're treating the cloud like someone else's data center, and the revenue has dropped off a cliff, user traffic has dropped off a cliff, and you just keep powering on as your infrastructure cost remains stagnant. That's not a great plan.
That's definitely not a great plan. This goes back to the unused resources that you might want to shut down.
It helps.
I think the way to do that, and this is some more of a deep dive into how Granulate does that, is we have a kernel module hooks into the scheduler, to the network, to memory, disk operations, all of these synchronization mechanisms that we just mentioned. And the reason being, we said there's no API to tell the kernel how to do that within the same process, so we had to create that API. And the same goes for the for all these runtimes. So if we talk about Golang or Node, you'll know that it's not about the context of a thread. With Go, it's a context of a Go routine, and with Node, it's always an asynchronous callback that is being processed by some worker. So you can schedule a different worker, but it might be the same callback that will be processed. So if you want to affect that, you have to do that within the context of the runtime itself.
No, that would make sense. You have to, there's only so much you can do at any given component.
Absolutely. So thankfully, and this is not directly related to Granulate specifically, I think this is agnostic to the architecture. When we talk about configuration tuning, when we talk about orchestration solutions, nothing is specific to a certain application or a certain environment. So it works anywhere from bare metal servers all the way to hybrid multi-cloud environments, Kubernetes, and so on. I think from a perspective of implementing, when would you imagine it would be best to implement such solutions for a company that is just in the migration process?
Oh, easy answer. Everyone's going to implement stuff like this after they really could have benefited from having it. It's one of those things that people care about after they really should have. Same way as, oh, I really should have looked at the bill, or, it would have been a good idea to renew my fire insurance. There's always the barn door after the horse has escaped story. But what makes something like this valuable during a migration process is the sooner you get visibility, the better. As far as what's going on in your environment, how you can optimize for this. There is the counter argument of let's do the lift and shift approach, which is not the worst idea in the world, though everyone loves to bag on it, where you change as little as humanly possible just so you can get an apples to apples baseline comparison before you begin optimizing. In practice, people forget the shift part. That tends to not be ideal.
So just in summary about specifically in this case for Granulate, since it's an agent installation, it's pretty straightforward. If you don't mind, I'll demonstrate with a single command line later, but obviously this all of these approaches actually could probably be deployed as part of whether it's the CI/CD process or a Chef script or Ansible script.
You absolutely don't ever want to wind up with something like this requiring someone to run a command arbitrarily. You need that. You've got to be able to demonstrate how this works and running it in a test environment manually. But once that's done, it has to be extensible. It has to be able to bake into whatever Byzantine software deployment framework any given company is using. And spoiler, by the time they're at the scale we're talking about here, it's going to be pretty nutty. So effectively accepting and embracing all different walks of deployment philosophy is critical for something like this. You have all the right boxes checked here from what I can see.
Sounds good. And from a past initiative agnostic, I think it's true for whether or not it's performance or costs. You can see a huge benefit from something like Granulate just because it's usually really overlooked. So obviously, you mentioned Brendan Gregg. I'm sure that at Netflix, they're, improving the heck out of everything to make sure that it's super tuned. But I bet that around 99% of companies don't have the resources to look so deep into the kernel.
Oh, I gave a talk once that was their theme was "You are not Netflix." People from Netflix need not attend. But yeah, this is the problem. We hear stories on conference stage about what the big companies are all doing, but these folks are generally at a scale that is orders of magnitude beyond what the rest of us are using. Solve the problem that makes sense for you. You're not going to hire a performance team in most cases until you're nearing that scale. But you can absolutely deploy something like this that starts giving better insights and better optimization stories around it.
Yeah, so completely agree. And I think it's also sort of agnostic to whether or not you did discount purchasing or right sizing. You could, as you mentioned, sometimes you could impact the revenue itself by doing that. And if you can impact the business, why not?
I take it a step further beyond that. If you wind up going ahead and rolling out something like Granulate, where you wind up optimizing and changing what your environment looks like, I would not necessarily make a committed purchase until after I'd figured out what the new normal was going to look like in my environment. Otherwise, you find yourself overcommitting and, well, that's great. We can run on smaller instances. We've already paid for the big ones. So there's really a net loss if we go down that path, depending on how it's structured. So measure twice, cut once before signing multi-year contracts is usually my approach to things.
Absolutely. You definitely don't want to come to an organization and just have them realize that they signed up for $100,000 saving plans when they actually need
I wish it was that small in some cases.
Absolutely. So I think in terms of the architecture, we've already mentioned that it works on any Linux machine. Every architecture. We've seen some really good traction with big data analytics, so Hadoop, Spark, Elastic workloads.
Do you support ARM-based architectures as well?
Yes, but don't tell Intel.
Yeah, of course not. Intel, yeah, there's only one processor manufacturer out there. So yeah, for those exploring some of the cost savings and performance changes around the ARM ecosystem that is still nascent but growing rapidly, that's nice to have with an eye toward the future.
Yeah, I think one of the interesting parts is that AWS claims Graviton to be the most cost-effective processor from a compute standpoint, and I think Granulate, and we've shown that in the benchmarks, operates pretty much the same. So I think this is a good opportunity to mention that as well. So you can see a Datadog screenshot that they sent us. So we don't aim to replace the monitoring system. You can see...
Which is good. It seems like there's an awful lot of companies out there that are trying to do exactly that. We usually choose to go on a path of least resistance. So if you're used to your own monitoring system, just go ahead and do that. That's why we support probably all of the deployment methods that you can think of, from Terraform to CloudFormation to Ansible, Kubernetes. Well, let's talk about that. Path of least resistance is always interesting. What is the engineering burden to go ahead and deploy Granulate, either fleet-wide or as a POC?
So that depends on how big you want to start. If you want to start as small as a single VM, you could have done that the same way that I just did the demo, with a single command line. If you want to start it with a service on AWS, you can either put it on a user data or Terraform, CloudFormation. If you have Ansible or Chef scripts, that's also something that we support. And if you've got Kubernetes...
Once it's deployed, it becomes a set it and forget it story by and large. It's not something that needs to be managed and tuned and tweaked, and now you have a team of 4 people whose sole job it is to poke and prod this thing.
Absolutely. I think we mentioned early on that we don't want any manual intervention when it comes to decisions about thread scheduling. So it's a nanosecond based decision. Obviously, no room for error.
So one thing that I always find interesting is it's pretty clear what some good example customers are who are using this in the wild. What's an example of a customer that wouldn't be a good fit for this? Who should absolutely not deploy this or come anywhere within 1,000 miles of it?
So I think the easiest example would be deep learning training or inference, for that matter. Anything that's GPU bound would be probably not a good fit for Granulate, because basically...
And let's face it, anyone who's doing deep learning or GPU-driven work is no way interested in saving money on anything, because the whole point of machine learning is generally that it can find anything except a business model. It feels like the epitome of hype-driven development, but I'm sure I'm making no friends with that observation, but that's okay.
Yeah, I think that's one of the those unpopular opinions. And I think that people with a deep learning workload would very much argue that GPU machines in the cloud are super expensive.
Yeah, but it's VC money. It's not real money. I'm just checking off the box of enemies listing as I go here. Why not? Yeah, no friends by the end of this one.
We'll probably edit it out for you.
No, it's fine. So it's clear that for real-time bidding type of stories where you have ad tech going effectively in real-time transactions where these tiny fractions of seconds matter, it's the people who are paying attention from that space have already been watching this video and started dialing and doing and setting up sales calls with you folks. It's one of those things where as soon as you see that resonate, they're interested. On some level, I would argue that, never having spoken to Bigabid, they're much more excited by the reduced latency than they are by the reduced cost. Would that be accurate?
I think to some extent it was, but you can see that they chose not only to take that latency reduction that we can see on screen, they also reduced their infrastructure size by 75%. So it's clear that they wanted, that they are enjoying the less timeouts. They're definitely enjoying the more successful bids, but they're definitely enjoying over $1.5 million in savings. So I think it's both, and I think when it comes to merely performance, it's mostly in streaming services that we've seen in gaming industry, where latency is king, and
right, because for an awful lot of these businesses who are watching this, they're going to see something like a 70% reduced P95 latency, and they will instinctively already have burned into their very souls the actual economics of what reducing that in their own environments would generate. And in some of the more interesting companies, that dwarfs any possible cost savings. Remember, there's a theoretical upper bound of 100% of your cloud bill that you can save, but the upside opportunity can be many multiples of that when brought to the right environment at the right time.
Absolutely. And we're seeing that also in fintech industry with fraud and payment solutions. That's usually a huge hit whenever you have an SLA breach. So for them, it was merely about latency. Just get me under that SLA. The cost is not the issue right now.
Right. If the answer is give me the biggest instances and all of them, great, we'll do that, because the contractual penalties are just monstrous.
Exactly.
And in some places, there's regulatory exposure.
Exactly that. Those are the exact places where we have offline installations, as you probably guessed.
I had sort of assumed that by you start talking about finance, then yeah, generally speaking, cloud services are still a bit of an open question for some of those companies. I get it. Change is hard.
I agree. The other example that we have here is a startup. Startup is in the same space, another ad tech industry company, but their case is on a data center. You can see that from a data center perspective, they chose to reduce about a third of their costs. But
it's harder to realize those big sweeping savings in a data center environment, because at some point you have to wait for the e-waste truck to show up and haul things out. And yeah, it's hard. And you also purchase the hardware in many cases. So it's difficult to say, oh yeah, so how much money did you save? Hey, Steve, what did we get on eBay when we sold those things? It doesn't work the same way.
So absolutely, what we call our reduced compute costs is being able to shift about a third of the compute to other projects. But you can also see that they chose to remain at almost 25% less CPU utilization than they were experiencing before, just to leave a little extra for that headroom, since they don't have
absolutely. And reduced CPU utilization at data center also means quieter fans. Everyone finds a benefit somewhere. Those of us who came up through being the data center climbing on the server types, oh, wow, I could wear slightly less thick earplugs. That alone would be worth the sale to me.
Yeah, I think something that actually resonates with a lot of our European clients is the carbon footprint.
Yes.
Yes.
That's a huge deal in its own right, where, especially in the data center world, that matters an awful lot. With cloud providers, you can make the right noises, but you're fundamentally outsourcing all of the climate and sustainability decisions to another provider with a couple of weird provisos in there. It's not the same burden of responsibility felt by most companies directly unless they're in data centers. And again, I think cloud makes sense for a lot of workloads, but I'm not a cloud zealot. If you have a business case for remaining in your data center, you're probably right. I'm not here trying to sell people things. Go where it makes sense for your workload and your constraints.
Absolutely. Yeah, I think that's what we had for today. Corey, any last words from you?
I would ask, at what point, from your perspective, does it make sense for companies to start using Granulate or testing it out? Because if you take my philosophy on this of wait until you wind up solving for all your RI buys and scale your environment and find the low-hanging fruit, then get into the really interesting deep stuff, companies don't ever think that they've solved those problems and they're going to wait forever. So when does it make sense for a company to start looking at this and realizing benefits from it without the view of the maturity model of you must be at least this mature and set some far future milestone?
So I think that's a fair question. And I think that it's one that I think not only we ask ourselves, but also our customers. And the best answer I could give you is the value, the time to value with Granulate is usually around 1 to 2 weeks. And I think that's where it starts to get interesting, because we've already seen that the R&D efforts are at a bare minimum of just inserting it into the deployment. And if it takes about 1 or 2 weeks to see it on a single VM or a couple of VMs, and then you can extrapolate for the rest of your workload or the rest of that specific service that you are testing, I think this is where it becomes really interesting, because it could be just as part of any other sprint that you're doing. And what we see is a lot of companies struggling with their scaling and out times, the warm-up times to do that. We see a lot of companies struggling to reduce costs with their Kubernetes services, with their, as you mentioned, Spark, Elastic, anything that doesn't necessarily scale in and out, but has a huge amount of compute into it. So this doesn't have to be put against other projects that are running, just because the amount of time, the average amount of time that customers put in is about 5.5 hours.
Excellent. Except for those of us with zero attention span, I think that that's a very reasonable time investment for something like this. The harder part, of course, then becomes validating it, figuring out what are the edge cases, how do we wind up fitting this into our current processes. But again, there's no such thing as an easy sale, especially with a company that is as scaled out as they would almost need to be to start realizing serious benefits about this organization-wide. Absolutely. It's an interesting approach. Thanks for taking the time to take me through it.
Thank you for joining us, and thank you for giving us your candid feedback. I'm sure a lot of VCs would be very upset with that.
Excellent. I look forward to enraging people still further. They know where to find me.
Thank you very much, Corey.